In this video, we're going to look at a simple investigation that you can set up for your children to help them inquire into and investigate friction, how to increase friction, how to decrease friction, and the different practical applications of that in the real world. So we've taught children by investigating Newton's first law of motion about friction, but now we want to sort of investigate how it works and why we need it in the world. That's always a really useful thing to do when teaching children about science is, why does this learning matter? You know, in this activity, I call it the sledge pull. However, depending on what's going on in the world at the moment, you can set different contexts around it. The basic idea is that we're going to create a sledge that we add items into the bag and it slowly pulls it. And we're trying to see which surface has the most friction, is the stickiest, has got the most grip, and which has the least. But you know, at the moment, we've just had the Winter Olympics, so a fantastic context for this experiment could be coming up with the best shoe for different Winter Olympic sports. For example, in curling, you need one shoe that's got a lot of grip and one shoe that's very slippy. Or in the bobsleigh, they need to have sprint shoes for the start where they can really grip the ice so they can run fast on it. So depending on what's going on in the world at the moment or your local context, you can contextualize this activity in lots of different ways. So how we set the activity up is we get 3 different surfaces and we put them on the table for the children to compare. Now, to make things as easy as possible, I've chosen to use non-stick baking paper, cling film, and kitchen foil. And the reason I've done this is it's cheap, it's easy to get, and it's easy to set up. But really, you could use any 3 types of materials that you can find around the classroom. You could use different fabrics or anything really that comes to hand. But certainly these 3 rolls of materials are very easy to find and very easy to use. The next thing we're going to do is to create our sledge. Now I've just used these intercollecting blocks, the kind of blocks that we'd find in classrooms all over the country, I'm sure. They're interconnecting blocks, and I've just made a sledge from them, put a rubber band around the sledge, and then onto the rubber band put a bit of string, and at the bottom of the bit of string I've sellotaped on a money bag. So it's a very easy bit of kit to make, and then we put that at the start of the material. The investigation that the children are going to do is how many blocks do they need to put in the bag before the sled is pulled. Now there's lots of great learning they can do here. They can be doing their predictions and then making a guess as to why, or what's their hypothesis. So which of the 3 substances do they think, or materials rather, do they think will have the most friction and why? How many bricks do they think for each? And they can have lots of discussion around that. Then it comes to the testing, and they're going to have to think about how can they do a fair enough test or a fair test. There'll be lots of great discussion and learning there. And then they'll be needing to use all their different scientific skills as they're doing this inquiry. They need to use their observation skills. When did it start moving? How many bricks did they put in? They'll need to do their recording skills, so making sure they're accurately recording how many bricks they went in. Make sure they're conducting themselves in a fair way. So if you have a quick look with this example then, I've got it on the baking powder, I've got my sledge, I'm going to start adding my bricks. 1, 2, 3, well, there's a bit of movement there. We'll wait and see if it's going to. So it's moving, but I'm not quite sure it's started. So the children might need to make a decision here. We added 3 bricks and it started to move, but it's now come to a stop. So the children maybe would want to record in that instance 3 bricks for when it started to move, but I'd say it wasn't enough to keep it moving. 4 bricks. 5 bricks, 6 bricks, 7 bricks. There we go. 7 bricks, and that's the sled pulled. We do the same thing with the different materials. Fantastic learning opportunity here for the children to really start investigating friction. And like I said, depending on the context that you've set it in, they could be trying to find the best surface for a shoe, the best material rather for a shoe that's going to grip on ice, or the one with the least. And it's a lovely opportunity to talk about with the children. You know, if you have a car and it's driving through poor weather, you want there to be a lot of friction so it can really grip the road regardless of the surface it's driving over. Even if it's driving over ice and snow, it's still going to grip. However, if you've got a fidget spinner, for example, those things that all teachers love, you want there to be very little friction so it can spin for a long time. Same with inside an engine. You don't want there to be lots of friction. You want the parts to be able to move softly over one another. So we know that engineers and scientists across the country in their different jobs are looking at ways either to increase or reduce friction, and there's a lovely context for that. Now, there's lots of ways that you can deepen this investigation. The first is by making an obvious link to maths. As the children are doing this, it's a fantastic opportunity for them to do all their information handling skills. So they can have their graphs to record the results, and then they can create that into different visual presentations. So whether that's a pictograph, or a bar graph, or a line graph, whichever way they want to show the results that they had. And it also means that if they're going to do a final report, they can include those visual representations, those bar graphs and those reports into that. So when they're saying, this is the material that I would choose for my shoe or for my bobsled, and here's why. You can see that this one held up to 9 bricks, whereas the other ones only held 3. So it's a great opportunity to tie in maths to this bit. If you wanted to have more opportunity, more investigation, then you could allow the children to actually wrap the sled in material as well. Now, as it is, we've only got 3 options. We've got baking paper, cling film, kitchen foil. But if we also allow them to wrap it, so it can be baking paper on baking paper, baking paper on cling film, baking paper on kitchen foil, straight away the number of options multiplies incredibly, and the children have a much larger investigation to do. What happens if you put a line of washing powder down, a line of olive oil down, a line of butter down, a line of honey down? How do these things affect the friction? And the children can make their guesses about that. Now, the best thing about using baking paper, if you choose to do that, is you can just fold it up and throw it in the bin, and there's not much mess, okay? You need to give your bricks a wash afterwards. So there's another way that you can investigate the use of lubricants or liquids and materials like that in friction. The last thing you can do, if you're looking to really take this learning quite a bit further, is you can start using a Newton meter. Now, a Newton meter is just a simple way of measuring force. You can see we've got a scale down here. On this side it's grams, on this side it's Newton. And we can just simply say to the children, this is the units of measure that we've got for force. So we want to work out how much force is actually being applied on the sledge before it pulls. And the simple way to do that is simply, once you're done, is pierce the bag. So the Newton measure, oops, I'll just do that quickly. So I've managed to pierce that bag now, and you can see that it's hardly showing at all. I'm not going to go and zoom in and read it to you, but the children can be recording those and actually thinking about how much force is being applied. So you've got one option where they're just counting bricks, which is fine. It's a fine way to do it. They're still understanding more or less friction. Or you can deepen it further by having them weigh the bags afterwards using a Newton measure, and actually you're starting to think about that right unit of measure. So there we go, that's a really useful inquiry and activity for the children to inquire into friction, to start thinking about how we can increase and decrease friction, how we can use different materials, and even introducing lubricants if we wish.